Good evening. All right, we're going to be talking about solving equations using addition and subtraction. You'll notice that my background looks a little bit different. I'm making this video at the conference center where I'm at today. So I try to make this as brief as possible. So this is Unit 4, and you'll be solving equations using addition and subtraction. Your learning intention is to be able to write and solve equations using addition or subtraction. You'll know that you are successful when you can apply the addition and subtraction properties of equality to produce equivalent equations. You can solve equations using addition and subtraction, and you can apply equations involving addition and subtraction to solve real life problems. So we're going to review a couple vocab terms that you have heard before, but we are going to use them often in this unit. So I wanted to make sure that you knew what they were. So the first one is equations. Equations is a mathematical statement where two expressions are equal. So you'll put expressions are equal. Okay, so if the expressions on both sides of the equal sign should be the same, and that's what makes it an equation. Inverse operations, now those are operations that undo each other. So in this little chart that I created you, if the given operation is an addition sign, our inverse would be subtraction. If our given operation is subtraction, our inverse would be addition. If your given operation is multiplication, inverse is division. And if you have division, your inverse would be multiplication. So let's look at some new vocab terms. There's three that we're going to focus on in this section of the unit. So the first one is equivalent equations. So how do we know if it is an equivalent equation? Equivalent just means equal. So equal equations. So two equations are equivalent, or I'm going to say equal equations if they have the same solutions. Okay, so if they both come out the same, then they are called equivalent equations. Then I have addition property of equality. So what this means is that adding the same number to each side of an equation produces an equivalent equation. What does that mean? So here's an example. If A equals B, then A plus C equals B plus C. So if these two are equal, then when I add A to C and I add B to C, they will also still be equal. Okay, let's look at subtraction property of equality. So subtracting the same number is going to be the opposite of what we did for our addition property. So we're going to subtract the same number from each side of an equation produces an equivalent equation. So that is just saying if I am going to subtract numbers from both sides, if I do it to both sides, it will stay equivalent. An example would be if A equals B, just like it was up here, then that means A minus C and B minus C are equal. Let's flip it around and apply this a little bit. Okay, so I gave you some steps here on how to get started. So step one, when you solve an equation, your goal is to get the variable by itself. Remember, the variable is that number or symbol. In this case, in this example, it's y. You want to get it by itself on one side of the equation. So in other words, you are trying to isolate the variable. Step two, when you are solving for a variable, you must, keyword there, use opposite or inverse operations to isolate the variable on one side of the equation. Then step three, whatever you do to one side of the equation, you must do it to the other side. of the equation. So in other words, you must keep the equations equivalent. Remember, equivalent is just a fancy word for equal. So here's an example. I start out with this problem, y minus 7 equals negative 3. So my first goal is to isolate the variable. I need to get the variable on the same side. So what am I going to do here? I need to get y by itself, so then I'm going to add 7, because whatever I do to this number, I have to do the inverse, right? So if it's negative 7, I have to add 7 to get it to disappear on this side. And then I'm going to add it over to this side. So that becomes y equals 4. Here's another example. S plus the 3 halves equals 1 half. I'm going to subtract 3 halves from both sides. 1 half minus 3 halves is negative 1, so S equals negative 1. Here's a try it section. You are going to solve the equation and then check your solution. So if I have t minus 5, let's do this one together. T minus 5 equals negative 3. I need to get t by itself. So I am going to use inverse operations to get rid of the 5 from this side. So if it's a negative 5, I need to add 5. And remember, whatever I do to this side, I have to also do to this side. So I'm going to add both. So this becomes t equals, what is negative 3 plus 5? Negative 3. So if I have a negative 3 and I add 5, I'm going to have a positive 2. So my answer is t equals 2. And this is check your solution. Well, how do I do that? I'm going to put this 2 in for t. So it's going to become 2 minus 5 equals negative 3. Now, does that work out? 2 minus 5. So positive 2 minus 5 equals negative 3. Yes, that is correct. So I know that I have done my work correctly. You're going to try that for 2 and 3. And then I want you to try some of these word sentences. So 3 less than a number r is 12. The sum of a number t and a negative 3 is 9. So what is 3 less than? That means that it's going to be subtraction, right? So I'm going to say 3 less than a number r. So I would say r minus 3 equals negative 12. That's what that's telling me. And now I can solve. You're going to say the sum. Sum tells me we're adding. The sum of a number t and negative 3 is 9. So how would you rewrite that? So rewrite it as an equation and then solve it. And then you have the total height of the Statue of Liberty and its pedestal is 305 feet. This is 153 feet more than the height of the statue. What is the height of the statue? See if you can write out this word sentence into an equation and then solve. All right, I'll see you guys tomorrow. Behave.